Hi class, this is lesson 7-4, special right triangles. Our first special right triangle is the 45, 45, 90 degree triangle, and this is our theorem about it. It says in a 45, 45, 90 degree triangle, the hypotenuse is the square root of 2 times as long as each leg. In other words, the hypotenuse equals the leg times the square root of 2. So 45, 45, 90, since this side is 45 and this angle is 45, since both are angles, I should say, are 45, that tells us that these sides are equal to each other, because it's really an isosceles triangle. So both the legs are x, they've got the same value, so our hypotenuse is x times the square root of 2. So this example says find the length of the hypotenuse for each of the following triangles. Well, this is a 45 degree angle, so we know this one's also a 45 degree angle. So it's a 45, 45, 90 triangle. And so our theorem, the hypotenuse equals the leg times the square root of 2 holds true. So my hypotenuse equals the leg is length of 6 times the square root of 2. So my hypotenuse is 6 times the square root of 2. And the next one, this leg and this leg are equal, so that tells us that these two angles are equal to each other. So it must be a 45, 45, 90 degree triangle. That's the only option for those two angles there. So I know it's 45, 45, 90. I know my rule, hypotenuse equals a leg times the square root of 2, still holds. So my hypotenuse equals my leg length, which is 4 times the square root of 2, times the square root of 2. And if we simplify that, we have 4 times the square root of 2 times the square root of 2 is just 2. So 4 times 2 is 8. So my hypotenuse is 8. Here's an on your own problem. Good idea would be to try this and make sure it works. It says find the length of the hypotenuse for the triangle at the right. This is a 45, this is 90, so we know this other angle is also 45 degrees. So these two are my legs, and I can use the formula hypotenuse equals leg times the square root of 2, because this works for a right triangle. So my hypotenuse is x, my leg is 2 times the square root of 2, and then I need to multiply that by the square root of 2. So x equals 2 times, well, the square root of 2 times the square root of 2 is just 2. So x equals 4, and that's the length of my hypotenuse. Well, let's try the next example here. It says find the length of the legs in the triangle to the right. So I know these two are equal, so these are definitely 45 degree angles, because if those two legs are equal, these two angles must also be equal to each other, and I'm told it's a right triangle, so it's got to be 45, 45, 90. So this x, that is my leg length, and this 9 square root of 2, that is your hypotenuse. So I know my hypotenuse equals my leg times the square root of 2. So the hypotenuse is 9 times the square root of 2, and that equals my leg, which is x, times the square root of 2. I want to solve for x, so I'm going to divide by the square root of 2. So I'm left with x on the right. These square root of 2's cancel, so I have x equals 9. And that is the length of each of my legs. And this last one on your own here, find the length of the legs of the triangle at the right. So again, I know my two legs are equal, making this, so it must be 45 here and 45 here since it's a right triangle. So this x, that is my leg length again. And right here, 12 square root of 2, that's my hypotenuse. So I'm going to use our formula for special right triangles. My hypotenuse equals my leg length times the square root of 2. So our hypotenuse is 12 times the square root of 2. And that equals our leg length, which is x, times the square root of 2. To solve for x, we're going to divide both sides by the square root of 2. So let's cancel. So I have x equals, my square root of 2's both cancel there as well, so I have 12. My answer is x equals 12, and that is the length of each leg. Let's look at the other side of this page. So our next special right triangle is the 30, 60, 90 right triangle. So we're looking at 30, we're looking at, oh, I'm trying to get my highlighter here, 30, 60, 90 triangle theorem. So these hold true when we got a 30, 60, 90 triangle. So for a 30, 60, 90 triangle, the hypotenuse is twice as long as the shorter leg, and the longer leg is the square root of 3 times as long as the shorter legs. In other words, my longer leg equals, I'm going to use S for shorter leg times the square root of 3. So let's use S. I'm going to use S for my shorter leg. And then I'm going to use a cursive L for my longer leg. So I could write the equation, my longer leg, so L equals S times the square root of 3. Now up above, right up here, it says the hypotenuse is twice as long as the shorter leg. I'm going to use H for hypotenuse. I also have my hypotenuse equals twice, so 2 times the shorter leg. So my hypotenuse equals 2 times S. So really, I have two separate formulas here, this one and this one. My longer leg equals the shorter leg times the square root of 2. My hypotenuse equals 2 times the shorter leg. So right here it says find the values of x and y. Write your answer in simplest radical form. Oops, simplest radical form. We got to watch for that one right here. So let's name all our sides to make sure we got them right. So if this is my 30-degree angle, my shorter leg is across from it. So this x is my S, 8 is my longer leg length, so that's my L, and y is my hypotenuse. So let's write our two formulas. We have longer leg equals shorter leg times the square root of 3. We also have hypotenuse equals 2 times the shorter leg. And let's fill in what we know. Our longer leg is going to be 8 equals, our shorter leg is x times the square root of 3. Now I can solve that one for x since I have only one unknown there. If I divide both sides by the square root of 3 to get x alone, I have x equals 8 times the square root of 3. Now we don't want a radical on the bottom, so I'm going to take 8 times the square root, or 8 over the square root of 3 and multiply it by the square root of 3 over the square root of 3. So that'll give me 8 square root of 3 over 3. And this is my value for x. So now let's use our second formula, the hypotenuse. So my h, that's really y, equals 2 times the shorter leg. My shorter leg is s, but I found that s is 8 times the square root of 3 over 3. So I need to simplify this. Y equals, and if I put this fraction over 1, just multiply across, 2 times 8 is 16 times the square root of 3 over 3. So there's my y. So I found my x and I found my y. 8 square root of 3 over 3 and 16 square root of 3 over 3. Next one on your own, it says find the values of x and y. Write your answer in simplest radical form. So again, I suggest you pause it and try this one on your own if you haven't already done it. All right, my shortest angle is, or smallest angle is 30, so my shortest leg is right here across from that. So 2 square root of 3, that's my s. My longer leg is going to be x right here, and my hypotenuse would be right here. Now there's no x on no y on my hypotenuse, so my y actually goes right there. So write that one in. X is your longer leg, y is your hypotenuse, and your shorter leg is 2 times the square root of 3. So let's use our two formulas. L for longer leg equals shorter leg times the square root of 3. And then also hypotenuse equals 2 times the shorter leg. So my longer leg is x equals, my shorter leg is 2 times the square root of 3. And then I'm going to multiply that by the square root of 3. Well, I can simplify that. So x equals 2 times the square root of 3 times the square root of 3 is just 3. So x equals 2 times 3 is 6. So there's one of my unknowns. That's just 6. My other one, hypotenuse, well, hypotenuse is y, equals 2 times my shorter leg. And my shorter leg is 2 times the square root of 3. This is 2 times the square root of 3. So y equals, I can combine these two, 2 times 2 is 4 times the square root of 3. And there's the y value, my hypotenuse. All right, let's use these a little bit more here. It says find the height of the equilateral triangle. So I'm going to draw right in here. This is the length that I'm looking for right here. I'm looking for that height of my equilateral triangle. And I can think of this really as being 2 right triangles. So there's one right triangle. Now let me label my pieces. This 12 is my hypotenuse. This H right here, that's going to be my longer leg, so my L, and the 6 is going to be my shorter leg. The way I know this, it's an equilateral triangle, so this angle must be 60 degrees. So that would make this definitely a 30, 60, 90 triangle. So to solve this, if I want to find my hypotenuse of the height of the triangle is right here, and that's my longer leg. So I'm really trying to find my longer leg in this problem. So my longer leg, L, equals my shorter leg times the square root of 3. So my longer leg, L, well, that's my height of my triangle. My shorter leg is 6, and then times the square root of 3. So my height is just 6 times the square root of 3. Next one, find the height of the equilateral triangle. So again, let's kind of define what triangle we're looking at here. We're just going to look at half of it. So we're looking at this triangle right here. And again, we know that if it's an equilateral triangle, this angle has to be 60 degrees. Right here, this has to be 60 degrees. I've got a 90, so this is degree angle right here. So this is definitely a 30, 60, 90 triangle. With this being 60, across from it is going to be my longer leg, so this is my longer leg. The 16 down at the bottom is going to be my shorter leg, and across from my right angle, that's going to be my hypotenuse. We want to find the height. The height is the longer leg, so again, we're going to use the formula L equals S, my shorter leg, times the square root of 3. My longer leg, that's my height. My shorter leg is 16 millimeters times the square root of 3. So my height equals 16 times the square root of 3, and that would be millimeters. And there's my answer. This is the end of lesson 7-4. Please make sure if you have any questions, you ask me about them in class, and have a great night.